Okay, we're on distance between 2 points along the latitude. We've done longitude. And as you can see from the diagram, for us to find the distance, assuming this, if you are given maybe this point A and point B, and we are asked to find the distance between these two, this is an arc of this circle. So if this is the center, so once we know this is the radius, this small r, let's use small r, because the radius of the earth, we normally use big R, which is 6,400 kilometers. So you see that, you notice that the radius we use for distance along the latitude is different from the radius we use, because they are not the same. It's only the equator that the radius is the same as the radius of the longitude. As you can see, if you connect here to here, is a big radius, which is r, because this is a big circle. So let's now find the relationship between small r and big R. So assuming we are given this, so if I join these points, I've joined some points. So if we call this the radius of the earth, that's the big radius for the R. So assuming from here, this is the center of this small circle. So if I call this the small radius, the radius of this small circle, so I want to relate small r and big R, but we need an angle. So assuming this is the latitude, remember we measure latitude from horizontal. So if I call this phi, so you can see that, remember this is 90, because this is a straight line, this is a triangle. So if you look at triangle, maybe let's call it triangle A, B and O, that's triangle OAB. If this is phi, this is also phi by alternate angle theorem. Do you remember alternate angle theorem? This is a transversal. So using our soccer tool from elementary trigonometry, that cos phi, cos is always adjacent over hypotenuse. So which implies that small r is always r cos phi, where phi is the common latitude. I told you, for us to find the distance along the latitude, we must have common latitude, but if it's along the longitude, they must have common longitude. R is the radius of the earth, while small r is the radius of the small circle, or maybe let's call radius of the latitude. Maybe let's write radius of the small circle. So each time we are to find, from what I just explained now, that if you are to find the distance between this A and B, since this is a circle, we know that the distance is always is a length of arc now. So angular difference, so depending the angular depending if they're on different hemisphere, even on this, as you can see, they're on different, so we add. So I will use the example times 2 pi small r. So we are not using the big R now, because we're on this small circle. So we use small r. So let me use the equation to illustrate this. So they say 2 points, this and this, are on the earth's surface. If it takes an airplane 10 hours to fly from A to B along the parallel of latitude, calculate its speed. Okay, we know that speed is always distance over time. So we need to get the distance first before we are given time. So once we know the distance, we found the speed. So let's draw the diagram. So look at my globe. So if I locate this is 30, so they say 30 north, 60 west. Why this is 30 north, 30 east. So they have common latitude of 30. So if we call here, let's call this 30, latitude 30 north. So why this is 60 west, why this is 30 east. So if I take this as my longitude 60 west, why this, let me take this as my longitude 30 east. So as you can see, both have common. So this is point A. Why this is point B. So want to get this length. So as you can see, this is the middle of this circle. So the radius we are going to use here is the small r, the same small r. So for us to get, remember we measure latitude from, let me use a straight line so that, okay, we measure, okay, let me just draw. So see what we have here. This is my axis, this B, and this is A. So this is my small r. So let me use 0 subscript 1 to denote the center here. So the first one is 60. So here is 60 west. Why this is 30 east. So my total angle is 90. So to calculate AB is very simple now. The angular difference is now 90 degrees. So 90 over 360 times 2 pi r. So times, let me use 22 over 7 times our r. Remember I told you small r. Small r is big R cos phi, where phi is the common latitude. Well, I proved it here. So the radius of the earth is 6,000. Always remember that 6,400 cos phi is 30 degrees. So this is 1 over 4. So this is half. You get this 120 over, so this is half times 22 over 7 times 6,400. Cos 30 is, I think it's root 3 over 2. So we can see that this is 2 to 11. So 11 times that is, so I have 11 times 6,400 over 14 times root 3, times root 3. So let's find the product. we have 11 times 6,400 times root 3 divided by 14. So we have 8,709.7. So we have 8,709.74 kilometer. But remember, we're asked to find the speed, not the distance. Therefore, the speed is 8,709.74 over 10 hours over 10. So this is now 870.974 kilometer per hour. But they say to the nearest kilometer per hour, so which is approximately 871 kilometer per hour, the nearest kilometer. So that's the answer. So please, whenever you're asked to solve this, just draw a clear diagram. You are good to go.